in black and white.
Why is it in black
Yeah,
and white?
I'll tell you later.
Grayscale.
All right, so let's get started. We're on to tangents and normals. So first, let's just do a recap of what a tangent is and what a normal is, and we're going to use our calculator to look at how we can use technology to assist us. So we're asked to find the tangent at x is 4 and the normal at x is 9. Let's go into our graph mode, and we're going to sketch the function y equals the square root of x. That's what we'll do first. So in graph, square root of x, and just set your v window as standard. Excellent. And then what we're going to press is sketch, which is F4. F4 corresponds with sketch. And notice there how we've got tangent and normal. Let's do the tangent first, which corresponds with F2. And we want to draw the tangent when x is 4. So we're going to press the number 4 and execute, and it will find the equation of the tangent and draw it for us. So mine's in green, and it tells me the equation of the tangent, y equals 0.25x plus 1. Okay? So what we can see...
Hey, where is it?
Where are you at?
So I might come around and see what you guys have. So here's our curve. We've got a line drawn here. Everyone got the line?
Mm-hmm.
Okay, press execute one more time.
Where is it?
Equals. All right, now is it displaying the line?
No.
Okay. Let me come and look at what you guys have. Might be a setting that we need to turn it on. So it's drawn the tangent. Yeah, cool. All right, I'll have a look at our settings later, but it will display the equation just above it. Mine does. Y equals 0.25x. Has anyone got the equation written there? No. Okay, so it's a setting that we all need to turn on that I've already got turned on. We'll have a look in a moment. Okay, what we can do as well is sketch the normal. So again, we'll go into sketch. We can press normal, and we want the normal when x is 9. All right, so this time we'll type in the number 9, and it's going to draw the line perpendicular to the curve, which means it meets the curve at 90 degrees when x is 9. Okay, so all I'm drawing out here is what each of these means. So a tangent is a line that's parallel to the curve, a normal is a line that's perpendicular to the curve. This is how we can use our calculator to find the equation of it. Okay, so for the normal, we've got minus 6x plus 57. Now, to find the equation of a normal and a tangent, there's basically about 5 or 6 processes we can use. I'm going to teach you 3, and I think you should be competent with all 3 processes, but then really it's up to you which process you would like to use. So let's go through. What we're doing is we're trying to find the equation of the tangent to the function root x when x is 4. So always for the equation of a tangent we need 2 things. We need the POC, which is the point of contact. All right? So for the point of contact, we have the x value, that's where we're drawing the tangent, and then we need the corresponding y value. Well, if the function, if we have y is root x, that's the function, we put x is 4 into this function, and we're going to get 2. Okay, onto the slope. All right, so we need 2 things. We need the point of contact, and we need the slope. Now, in order to find the slope, this is where the differential calculus comes in. We need the slope function. This is the function, y equals x to the half. We need the slope function, which is the derivative of this one. All right, so dy and dx will be half x to the minus half. Okay, so that's our slope function. And we're going to use the slope function to determine the slope when x is 4. So we're going to put 4 into the slope function. So we can go, when x is 4, dy on dx is 1 on 2 times the square root of 4, which is 1 on 2 times 2, which is 1 on 4. We have a slope of 1/4. Okay. Now here, this is again, we know how to use our calculator to support us here because we could type this into our run map with x is 4. Find the rate of change, find the slope when x is 4 for this function, and it would dish that out for us. Okay, now we've got everything we need for the equation of a tangent. So we're always finding the two same things, the point of contact and the slope. Point of contact and the slope, we've got both. So now all we're doing is finding the equation of a line with these properties. Has a slope of a quarter, passes through this point. So we know the equation of a line, y equals mx plus c. We know the slope is a quarter, so we have y equals a quarter of x plus c. We know it passes through, x is 4, y is 2. So we're going to plug that in. We have y is 2, x is 4, c is 1. Therefore, the line is y equals a quarter x plus 1. Now we've expressed this line in y-intercept form. When I g-solved it on my calculator, it popped up as 0.25x plus 1, exactly the same. All right, you can express it in either way. Our calculator can check for us. So that's a process I would hope that we're pretty comfortable with, okay? All you're doing, finding the point of contact, find the slope. Once you've got both of those, you're just finding a line with those properties. And what we're doing is we're using a fairly intuitive process to find the equation of a tangent, right? A line with these properties that we found. Excellent. Let's move on to the normal when x is 9. Okay, so we're going to find the equation of a normal when x is 9. Now, for a tangent and a normal, we still need the same properties. We're going to need the point of contact. This time we have x is 9. And so when the x value is 9, then the y value is going to be the square root of 9, which is 3. All right, next we need the slope. Now, we've already found the slope function. We don't need to repeat that. Here, this is the slope function. This will tell you the slope for any value of x. So if we want to know the slope when x is 9, it's going to be 1 divided by 2 times the square root of 9, which is 1 on 2 times 3. It's 1 on 6. Now, this is the slope of the tangent. It's the slope of the curve at that point. The normal is a line that's perpendicular to the curve. So this is the slope of the line that's parallel. It's the slope of the curve. We need the perpendicular slope to this. Anyone remember? The reciprocal times minus 1. So we're going to flip it and make it negative. Okay? A perpendicular line will have the negative reciprocal slope. So we're finding a line that has a slope of negative 6 on 1. Now this one we might do in general form, I think. So we've already used an intuitive process here to find the equation of a line. You could repeat that again, okay? We have a line that has a slope of, you can express it as minus 6, a slope of minus 6 and passes through 9, 3, y equals mx plus c. That's the y-intercept process. Y-intercept form process, we're familiar with that. But let's have a look at general form. So I might write up the notes for general form and talk about how we can relate to it. Because general form, people tend to not be very comfortable with. So I'll just make sure you've got it written down as well. We do, yep. So you've got, we write it a number of ways, but if slope is minus a on b, then ax plus by equals capital C. Now this is not the y-intercept. And if slope is positive a on b, then ax take by equals c. So this is how we solve the line in general form. All right, that's the rule. That's the general rule. That's always going to be the case. So let's have a look at our slope, and we've got it here expressed as a fraction. That's useful because we want it expressed as a fraction. And we can see the slope is negative 6 on 1. So that means our 6 corresponds with A and our 1 corresponds with B. So we're going to write this 6x plus 1y equals C. All right, I've just substituted it into the general form. Then the way we would determine the value of C is like all of the other processes, we substitute the coordinate in. The coordinate that it passes through, our point of contact, x is 9, y is 3. X is 9, y is 3. So let's put in x is 9, y is 3. 9 times 6 is 54. 54 plus 3 is 57. Okay, so therefore, the equation of the line in general form, 6x plus y equals 57. Alright, so that's it expressed in general form. Now we saw before, when I found it with my calculator, it was minus 6x plus 57, y by itself, that's y-intercept form. And we can easily convert that to y-intercept form by moving the 6x over to the other side.
So you said that the
Minus 6x
C was
plus
for
57.
y-intercept.
It sometimes is, but not exclusively. So as a general rule, the answer is no, it's not. Yeah, it is in this circumstance, yeah, but it's a fluke. It's more often not than it is. Okay, so we've done 2 there. Let's move on to the third one. Is how does everyone feel about general form? Do we want to do general form again, or do we feel okay about that process?
More general.
More general form. So let's do the next one in general form, or maybe even then we'll do both processes. I'm just going to spin the board. So we have sine x at x is pi on 3. Y equals sine x at x is pi on 3. Okay. So we need 2 things. We need the point of contact. All right. Our x value is pi on 3. Our y value is sine of pi on 3. All right, which will be root 3 on 2. All right, now we can get that from our calculator. We can get that from our unit circle. We're just going sine of pi on 3. Next, we need the slope function. Okay, so we have y is sine x. And so then the derivative of sine x is cos x. And we want to know the slope. We want to know what's the value of cos x when x is pi on 3. Cos of pi on 3? Half. Okay. So now we have the equation of a line. It has a slope of half and it passes through this point. All right, let's do both processes from here, okay? So we're going to do the general form and the y-intercept form. We'll start with the general form. All right, for general form, we have a slope of 1 on 2. That means we're going to have 1 lot of x, take away 2 lots of y, equals c. We substitute in the coordinate that we're provided. We have x is pi on 3 and y is root 3 on 2. And so this will simplify to be pi on 3 take root 3. So therefore the equation of this line in general form, x take 2y equals pi on 3 take root 3. Now what we've found here is we've found it in exact form. Over here, this is going to be an irrational number. It's going to be a double irrational number because we have a surd and we have pi. So this is going to be a super irrational number. So here we've expressed it exactly. We've accounted for every possible decimal place. Whereas if you do it in your calculator, that's going to pop out as a decimal. So that is one of the defects of the calculator, is it won't always show you the exact solution. Okay, general form, we have here ax take dy equals c, that constant term. All right, so that's the general form process. Let's have a look at the y-intercept form process. This is the one we should be pretty familiar with. We have y equals mx plus c. That's the equation of a line. We have the slope is half. So we're going to put half where m is. And then it passes through when x is pi on 3, y is root 3 on 2. Now I'm going to take away that term from both sides. So we'll have root 3 on 2, take pi on 6. And if we times both sides by 2, we'll have root 3 take pi on 3. We don't have to do that, but I'm just pointing out how they're the same value in this circumstance. Okay, so the equation of a line then, remember, y equals mx plus c. We have y equals half x plus, what's the c value that we found? Root 3, take away pi on 3. All right, and it's perfectly suitable to express it like that. You could collect them, but we don't need to. All right, so I might stop there so you guys can have a bit of a practice with both processes before I reveal another one. Whoop.
Didn't you have to make it 2C if you times the x by 2?
Yes, yeah, you're right. I can't do that. That would say 2c, wouldn't it? Yep. Yeah, good call. So that should say root 3 on 2, take pi on 6, because they're not the same. They look the same. The reason they're not the same is because we don't have one lot of y, we've got two lots of y. Thank you. So yeah, we can't do that. It would say 2c, and then we would have, yeah, that's an illegitimate operation. All right, so yeah, what I'd like you to do, have a practice of general form, have a practice of y-intercept form, and then we'll look at another process a bit later this lesson using a formula. But I want you to be sort of comfortable with both processes. So maybe as we're doing the questions, just try one way and try the other way. Make sure we know how to do both. Cool. All right, so let's get into it.